Hello students, let's begin on today's topic, electric cell. So what is the electric cell? You know very well, a cell has two terminals, positive and negative. Positive means the anode, it is the anode, and the negative means the cathode. Okay, so it maintains the supply. It maintains the supply in the circuit. This is the main function of the electric cell. Okay, and also it converts, if we talk about the electrochemical cell, so it converts chemical energy, that is the energy provided by the electrolytes into the electrical energy. Okay, so it converts chemical energy into the electrical energy. And you know very well, cells are of two types, primary cells and the secondary cells. Okay, primary cells cannot be recharged again and again, and the secondary cell can recharge again and again. Okay, this is the main difference. Now we'll discuss a very important topic of this chapter, that is the electromotive force, which is also known as EMF. Okay, so first of all, see what is the EMF of a cell. Actually, cell has to do the work from one point to the another point. As you know, the potential difference is the work done in carrying unit positive charge from one point to the another point. But in a cell, the work is including the work inside the electrolyte also, because in terminal from one terminal to another terminal, that is the potential difference, or the terminal voltage, it is also known. But when you include the work done inside the cell, that is from negative to positive also. So if you add these two works, external plus internal, so total work done is known as the electromotive force. So electromotive force, if we define it, work done, it is the work done in moving a unit positive charge through the complete circuit. Okay, through the complete circuit including cell is known as EMF, or electromotive force. So definition, the formula is E is equal to W upon Q. It is denoted by capital E. Okay, and remember the SI unit of the E is the joule per coulomb. Okay, which is also known as the volt. This is the unit, already you know. And remember, it is a scalar quantity. Okay, and secondly, its dimensional formula is ml square t minus 3 a minus 1. Okay, so this is the dimensional formula of the electromotive force, EMF. Now, to much more about the EMF, we should know about the internal resistance, a very important topic. We should know about it, internal resistance. And remember, it is denoted by small r. You know very well about the external resistance, which is denoted by capital R. But what is the difference between the internal and the external? Actually, in every circuit, the conductor provides the resistance in flowing of the charge inside the conductor. That is the obstruction in the path of flow of the free electrons. That is the external resistance given by the conductor. Okay, now internal resistance, it is the resistance offered by the electrolyte inside the cell. So that's why it is the internal resistance. So we can say this is the during the definition, during the flow of current flow of current, the resistance offered by solution. Solution means the electrolyte. Electrolyte of cell is known as internal resistance. Internal resistance is small r. Remember this internal resistance, that is this is the electrolyte, this is the positive, so this is the capital R. So cell provides the internal resistance. It is the positive, it is the negative, so inside it is negative to positive. So it depends on few factors. It depends on three factors, you can say 3 or 4, you can say. First is the distance between the electrodes. More distance, it will not easily reach from one electrode to the another electrode, so it means it will increase. So distance between electrodes, between electrodes, if you say it is suppose D, so in that case you can say the R directly proportional to D. And second point, you can say area of plate, area of electrode, you can say area of electrode. More area, it means the more free electrons will reach there, it means the resistance will be less, means the current will be more. So R inversely proportional to the area of cross section, area of the plate. This area, if the area is more, then what will happen? Area is more, in that case more electrons will reach there and the resistance will be less, you will find the more current. And the third is the, you can say it is the concentration. Nature and concentration. Concentration of electrolyte. Nature means what is the solution. Suppose it is ammonium chloride or some other. So nature, so current depends on the nature of the electrolyte. And the concentration means the density. If the electrolyte is more dense, it means the free electrons, or you can say the ions, will not move easily from one point to the another points. So that's why by increasing the concentration, less ions will reach from one electrode to the another electrode. So you can say resistance will increase by increasing the concentration. And the one more point you can consider, it depends on the temperature. Temperature of electrolyte. You can say the R are inversely proportional to the temperature. Means when we give the temperature, give heat to the electrolyte, what will happen? It will be diluted, and then now free ions will get more energy and they will reach easily from one electrode to the another electrode, so current will flow more. It means by increasing the temperature, resistance will become very less. Means the more current you will find, or in other words you can say the resistance will reduce by increasing the temperature. Now we will find a relation between the internal resistance, a very important topic for your exam, relation between R EMF and the terminal potential difference. That is the potential difference between the terminals, between the electrodes. See and try to understand. Suppose it is a cell, like this. It is the electrode, positive and negative, anode and the cathode, you can say. So this is the capital R and this is the electrolyte. So Now the charge has to complete its path from positive through the external resistor, and then to the negative, and then again from negative to positive. Okay, it means work can be divided into two parts, that is the work external plus work internal. It is the external and this is the internal. Okay, two work will be done here, and that will be equal to the total work done. And you know very well total work done. Now I'm taking the total work done. First we'll take the total work done. Okay, total work done, that is the W. It is equal to, because it is the work done including the electrolyte, is called the EMF. So EMF from E is equal to W upon Q. So W is equal to EQ. W is equal to EQ, or Q is equal to IT. So it is the EIT. Okay, this is the total work done. Is it clear? Total work done from the definition of the EMF. Now to find the external and internal. Okay, external work done from the definition of the potential difference. So since V is equal to W upon Q, or W, it is the external. Okay, external. W is equal to V into Q, and Q is equal to IT. So it is the VIT. This is the second equation. It is the second. Now to internal from the definition of V is equal to WQ. V, this is the potential drop, you can say. This is the potential drop in the electrolyte. So V is equal to W into Q, and W is equal to you can write, it is the I from the definition. We know W is equal to IR, or we can write W internal is equal to IR. V is equal to IR. Put here small r. Put is equal to here like this here. V is equal to IR. Here R is the internal resistance. Is it clear? So V is equal to IR. Here you will write, and Q is equal to IT. Q is equal to IT you will write. So put here W from the definition of that is the W is equal to V into Q. Okay, make it correct. V is equal to here IR, and Q is equal to IT. So it is I square RT. This is the third one. To make it correct. Okay, make it correct. It is correct. Okay, now as you know, total work done is equal to external work done plus internal work done. So it is EIT. Total means EIT is equal to external. What is the external here? From the second, it is the VIT, and the internal, it is the I square RT. So we can write VIT plus IRIT EIT, and you can cancel IT from both sides. So it is E is equal to V plus IR. This is the desired expression. This is the desired expression of the electromotive force, and this is the relation between the electromotive force and the terminal potential difference between the electrodes, and the internal resistance is small r. So remember this relation, and from this relation it is some points must be clear to you. So first point, you can say, in the first point, from E is equal to V plus IR, Okay, we can say the V is equal to E minus IR. It means when current draws, V is always less than capital E. Okay, V is always less than capital E. Okay, remember. And the IR is also called back EMF. Okay, remember IR. This is called the back EMF. And the second point, you can say when no current you are drawing, that is the I is equal to 0. In that case, V is equal to E. That is the terminal potential difference is always equal to the EMF of the cell. Okay, remember, it's very interesting. And the third, you can say from E is equal to V plus IR, we can write R is equal to E minus V upon I. Is that clear? And but I is equal to V upon R you can write. So here we can write E minus V upon R, or simply we can write R E upon V minus 1. Okay, so this is another relation will be used in a very important topic, that is the internal resistance by the potentiometer. Okay, we'll discuss this equation also, very useful. Okay, and another form we can say here, since E is equal to V plus IR and V is equal to IR, here put here small r, so we can write E is equal to V means IR plus I small r, or IR plus R. So we can write I is equal to E upon R plus R. So the current in the circuit is always equal to the EMF divided by the total resistance, that is the internal plus external. Okay, and one more point you should know, if during the charging of cell, okay, put I is equal to minus I. Okay, direction will be changed. So in that case, V is equal to E plus IR. That is, V is always greater than the EMF. Okay, so remember these important points, and in next topic we'll discuss about the combination of the cells. Thank you, students.